All right, so welcome to this class. It's our first class in chemistry, and we are going to be looking at units and measurements. My name is Tutor Solutions, and I hope you guys are going to enjoy this class and are going to learn something. Okay, so serious classes at your university are not going to start until, I think, until January. That's when serious lessons are going to start. So starting November, December, you guys will just be playing around. Okay, so you have to use this time to actually understand the basics of whatever you're going to cover in all the courses. So in chemistry, make sure you understand all the basics. In physics, make sure you understand. In math, make sure at least you know everything about sets come January. And then also biology, make sure you know the first topics, like you are going to be talking about the type of microscopes that you use. Know all that from now until January. Because when January comes, the lessons are going to be they're going to be all over you. Okay. There's going to be a lot of pressure that will be applied on you guys. So it's better to start early so that you avoid the pressure. All right. So if you have any questions as we'll be learning, you can easily unmute yourself and then you can ask your questions. Okay. So we'll be looking at units and measurement part one. So in part one, we're going to discuss the following. We're going to define what a measurement is, okay, and then also give an example of what a measurement is. Number two, we are going to talk about the base units of measurements. Okay, so there are just 7 of them, and from the 7, we get all the other units that you can think of. So there are just 7, and then from the 7, we get billions and billions of units. Okay, and then from there, we're going to look at the metric system, okay, which is just a system of multiples and sub-multiples of 10. I'm going to explain what it is. And then the last objective of this lesson is we're going to do examples on unit conversions. Okay, we're going to do examples on unit conversions. All right, so let's start. So by definition, we say a measurement is a quantitative observation consisting of a number and a unit. Okay, so that's the definition of what a measurement is. So this means that um, any measurement, okay, or something, for something to be a measurement, then it has to have a number and a unit. Okay, so this word here, the quantitative here, it means that in these measurements, we actually use numbers. Okay, in the measurements, we actually use numbers. And then observation simply means something you can observe or something you can read using a what? An instrument. Okay, so if there's a quantity or a quality that you can read or observe, then that's an observation. Okay, and then this quantitative observation should consist of a number and a unit. Okay, so for example, if I write 10 kg, okay, if I write 10 kg here, this here is going to be a measurement. Why? Because there is a number, the 10. Okay, I should get a black. So there's this number, the 10, and then there's this unit, the kg. Okay, so if you combine a number and the unit, okay, then you get a measurement. Okay, so that's the standard. Okay, so a measurement should always have two parts. There should be a number, and then there should also be what? A unit. So the number tells you how much of something that you have, okay? And then the unit tells you of what. Okay, so that's the definition there. And then we move to the base units of measurements. So they're just 7. These are the ones that I've outlined here. So the first one is the length. Then we talk about mass, time, electric current, temperature, the amount of substance, and then 7, luminous intensity. Okay, so all the other units that you know, the joules, okay, the pascals, they all come from these base units, which are 7. Okay, so the first base units that we have is what we call as length. So length is usually represented by L, or it can be X, okay? And then when you go to physics, this length is also represented by S, like this. Okay, so L, X, or S is going to be representing length. Okay, so this length is measured in meters. And then the symbol for the meter is a smaller letter, what? M. Okay, so that's the first base unit that we have. And then we go to mass. So mass, okay, its symbol is just a small letter M. It will mean you are talking about mass. And then its base unit is the kilogram. So the symbol is just the kg. And I know you are quite familiar with the kg. Okay, because you buy meal, you buy sugar, uh, those are measured in kgs. And then the other one is the time, which has the symbol T, small letter t. And then its base unit, okay, time is measured in seconds. Of course, it can be converted to minutes, hours, days, weeks, years, okay? But its base unit is just the second. All right, the other one is electric current. So this is represented by I, and then it's measured in amperes, and then the symbol for the ampere is simply the A there. Okay, and then we also have the temperature being represented by a capital letter T, and its base units, okay, are the kelvins. So most of you are used to the degrees Celsius. So now when you come here at the university level, okay, temperature is always going to be measured in kelvins. Of course, they can give you temperature in degrees Celsius, but in your calculations, okay, most of the calculations that we're going to be doing in chemistry as well as in physics, they require that the unit for the temperature is what? Kelvins. So we're going to see later on how we can convert this degrees Celsius to kelvins and vice versa. Okay, and then on number 6 here, I have the most important unit that you need to know in chemistry. Okay, so and that is just the mole. Okay, so the mole is a measure of the amount of substance. So the amount of substance is represented by a smaller letter N. And then its unit is the mole, and then the symbol is MOL. So this guy here, the amount of substance, or when we talk about moles in general, is what you'll be doing throughout chemistry. Okay, you need to find the mole of something. And then once you find the mole of something, you use it to find whatever you are finding. So you need to know, understand the moles, okay? Because they'll be appearing everywhere in your chemistry course. Okay, and then the last one is the luminous intensity. It's measured in what we call as candela, and then the symbol is CD. So the luminous intensity, you guys are not going to really talk about this, unless for those who are going to major in physics or major in chemistry, that's where you find the luminous intensity. But for you, other guys, and most of you, it's just going to be the first 6 here. So length, mass, time, electric current, and then the temperature. Okay, you're going to see that even in the test papers, I'm going to show you a question that came. You're just supposed to write this table the way it is, and then you get 10 marks. So those are free marks that you guys should be getting. Okay, so these are the base units here. So if you have any questions, you can simply ask me. Otherwise, I'll go on and talk about the metric system. Okay, so the metric system is just a system that consists of multiples and sub-multiples of 10. Okay, so if I write 10 here, okay, this 10 here, 10 here, okay, I can have its multiples and also its sub-multiples. So by what do we mean by its multiples? Okay, so the way I've written 10 here, the way I've written 10 here, it's the same as I write 10 to the power 1. Okay, so 10 on its own is the same as 10 to the power 1. And then now I start multiplying 10 by itself, okay, by a specific number. So if I multiply 10 by itself 2 times, then I'm going to have 10 to the power 2. If I multiply 10 by itself 3 times, I'm going to have 10 to the power 3. Okay, and the pattern keeps on going until whatever number you can reach. You can even reach 10 to the power 15. Okay, so you can see that the first one there was just 10 or simply 10 to the power 1. And then I'm increasing the powers like that. So these ones here are called multiples of 10. Okay, because you are multiplying 10 by a specific number. So they are multiples of 10. Okay, and then if from this 10 I say I have, okay, from this 10 I say I have 10 to the power 0, okay, or I have 10 to the power minus 1, or I have 10 to the power minus 2. So you can see that as I go up there, I'm starting to reduce the number, right? So this was 1, then it becomes 0, then it becomes minus 1, then it becomes minus 2. So if I'm reducing the power from 10 to the power 1 to 10 to the power 0, 10 to the power minus 1, 10 to the power minus 2, then those are called submultiples of 10 because they have a negative in the power there. Okay, they have a negative in the power, so they're called submultiples. So this is what the metric system is. So it's just a table that shows the multiples and the submultiples of what? Of 10. So you can see here, if I can start from this, you can see that that one there was just 10 to the power 1. And then as I go down here, the powers are increasing. This is power 2, power 3, power 6, power 6, power, oh, this was power 9, power 12, power 15, power 13, power 21, all the way to power 30 there. Okay, so these are multiples of 10. Okay, I even wrote it on top there. You can see here I wrote multiples. Okay, so these multiples here, okay, they have one, a symbol and a prefix. So a prefix is a name that is going to be attached to that multiple of 10. And then the symbol will just be the symbol that represents the what? The prefix. So whenever you see 10 to the power 1, it's equivalent to saying deca. Oh, okay. It's equivalent to saying deca. Or I give the most common one. We've seen that we buy millimil, right? We buy that 25 kg or bag of millimil. So this K here in the kg for the bag of millimil is what we call as kilo. Okay, so kilo is attached to 10 to the power 3. Okay, 10 to the power what? 3. So whenever you see K, kg, okay, that is 10 to the power 3. So this guy here, the K, represents 10 to the power 3. So that 25 bag of millimil is the same as 25 times 10 to the power 3 and then grams. But this one here, they just remove it and then they put a what? A K, because a K and 10 to the power 3 literally mean the same thing. Okay, so you can see that we have a lot of multiples here and all of them have different names. Okay, so those are the things that are going to be helping you when you're converting units. So because they will give you maybe they say okay, they give you 10 kg and then they tell you to convert this 10 kg to grams. Okay, so how are you going to do that? You're just going to replace this K here by its value, okay, by its value. So if you don't know the metric system, then how are you going to convert there? Okay, there is no way that you're going to convert. So you have to know these what multiples and submultiples of 10 from the metric system. Okay, so as I was saying, the deca is just 10 to the power 1. So these things have to be in your head because they won't give you this table when you're writing a test or a quiz on an exam in an exam. They won't give you this table. So it has to be in your head. So 10 to the power 2 hecto, 10 to the power 3 kilo, 10 to the power 6 mega. Okay, at 10 to the power 9 giga, 10 to the power 12 tera. So for you guys, you just only have to know these ones here that I've put in a carried box like that. Okay, because they are the frequent asked ones in questions. Okay, so they can give you maybe 10 giga, 10 gigabytes if you are measuring bytes. Okay, so 10 kilobytes. Those are the units that we use for the storage in our phones, in our PCs. Okay, we say maybe this phone is 128 GB. Okay, you even write GB like that. So this one here is a measure of storage. Okay, so it's just the bytes. And then this guy here, the G, the capital letter G. When I come here, you can see the G is the same as giga. Okay, and then its value, this giga, whenever you see capital letter G there, it's the same as 10 to the power 9. Okay. If you see mega, it's the same as 10 to the power what? 6. If you see kilo, it's the same as 10 to the power 3. So you have to know these ones here that are highlighted in red. They are the most important ones. And they ask questions on those quite frequently. Okay. Oh, another example is I know you guys love Facebook. Okay. But as you start school, you have to reduce because there will be no time for Facebook anyway. So on Facebook, when someone posts something, right? You see like on that like button, there'll be like maybe they'll say 17K. So this 17K means what? Okay, it just means that 7,000 people like the post. Okay, that's what this 17K here. Or on the big pages, you can see maybe looking at a post for Ronaldo or Messi, you see that on that like button, there will be like 1M. So that 1M simply means 1 mega. Okay. And that means what? A million. All right. So you have to know this. And then we also come to these ones, which are submultiples. So the submultiples have the negative powers. You can see them there. Okay. So the most important one that you must know are these ones here. Okay, so from the deci, centi, milli, micro, nano, and the pico. And then also you have to take note of their symbols here. Very important. Okay, when they say deci, it's a small letter D, centi, small letter C, milli, small letter M, micro. Here, most people here make a mistake because when they hear micro, they just write maybe micrograms. But this small letter M here indicates the milli here. Okay, so you have to be careful on the micro. The micro has another symbol, which is this guy here. So this guy here is mu. So we call this guy here mu. It looks like a U. Okay, so micrograms. So the micrograms, the micro will be represented by the symbol mu, which looks like a U. And then the nano is just small letter N, the pico, small letter P. Okay, so you have to know the symbol for each of these prefixes, and then uh, the numerical value here. So if I say pico, okay, I have to know that that is 10 to the power minus 12. Nano, I have to know that that's 10 to the uh, power minus 9. If I say micro, I have to know that okay, that's 10 to the power minus 6. Okay, I remember when I was in first year, as we even made the song. Okay, we are singing it every day so that we easily remember. Okay, so we're singing it. How was that song? It was like Pika Nano Micro Midi Centi Deci Kilo Mega Giga Tera. Then if we've moved from here, we've reached there. And we know that the first one, it will be minus 12, okay? And then the next one will be minus 9. So it's like they reduced by 3. You can see this is minus 12, then minus 9, minus 6, minus 3. And then when you reach minus 3, they start reducing by 1. So you get minus 2, minus 1. Okay, and then here 1, 2, 3. When you reach 3, they start increasing by 3 again. So 6, 9, 12. So you have to know these 12 that I've highlighted there. Then you'll be good to go. Okay, as long as you know the numerical value, you know the prefix, which is simply the name of that value, and then you also know the symbol that what represents it. Okay, so any questions there, guys, on what we've discussed so far? Any questions there? Okay, don't feel shy. You can ask me questions so that I explain and you guys actually understand. Okay, so if there are no questions, we'll continue. Okay, but remember what I said on the metric system. So for you to convert units, you have to know the metric system. So the metric system, okay, what do you know from there? You have to know the numerical value, which we are calling the factors. So this 10 to the power somethings, the prefix, which is just the name there, okay? Like these ones here, they're just the name of the unit of the numerical values. And then 3, the symbol. Because when they give you the units, they're just going to give you the symbol. So you have to know, okay, this symbol represents um, such a quantity, okay, or such a value. All right, so let's move now so that now that we have known the metric system, okay, we can easily convert units by using the what? The metric system. So there are actually 2 methods for converting units. There's one which we are going to do today, okay, which is by the metric system. And then there's another one where you use dimensional analysis, okay? So when you're using the metric system, then the units that you are given in that measurement will just be 1. But when you're using dimensional analysis, okay, then the units that will be given in that measurement will be 2 units in one measurement. Okay, so for example, you remember how we're measuring density at grade 12, right? So we would say maybe the density is 1.2 grams per cubic watt centimeter. So when you are converting such measurements where there are 2 units attached like that, we're going to be using dimensional analysis. So that will be for the next class. And then in this class, we're just going to be using what? By metric system. So meaning we're just having 1 unit. So for example, 5.2 nanometers. So how can we convert this to meters? That's what we're going to be discussing in this video. Okay, so let's look at some of the examples on how we do these things. So for example, if the question is convert, okay, 5.2 nanometers to picometers. Okay, so if I'm converting these units here, what am I going to do? Okay, what am I going to do? So remember the metric system, so I just have to remember the values for the metric system, okay? And then I have to come and replace these guys here. So we said nano, okay? We said nano was 10 to the power what? Okay, so said nano was 10 to the power minus 9. And then pico was 10 to the power minus 12. Okay, so how do we convert 5.2 nanometers to picometers? We are going to say this value, the way it is, 5.2 multiplied by, okay, this one here is nanometers, right? So I'm going to replace the nano by 10 to the power minus 9, okay, divided by, of course, the meters is still there. So divided by, okay, divided by the prefix of where we are going. So the prefix of where we are going is the pico, right? So the pico has the value of 10 to the power minus 12. So I'm going to divide this by minus 12 like this. So I'm going to say equals. So this here is the same as 5.2. And then you remember when you are dividing bases, okay, that are the same and then they have different powers, what do we do? So in grade 12, we said, if for example, I have x to the power n, and then I have x to the power y. So I'm dividing this and they have the same bases, right? So what do? I combine these ones as x to the power n minus y. That's what we did in grade 12, right? Okay, so that's what I'm going to do here on these two. Okay, so I'll leave the 5.2 alone, and then I'm going to say this one here is the same as 10 to the power minus 9 over 10 to the power minus 12. So that will just be times 10 to the power minus 9, and then minus the power which was down there, which is minus 12 like this. So this will be 5.2 multiplied by 10 to the power minus 9 plus 12. So this will be 5.2 multiplied by, this will be 10. What is it? 12 minus 9, or minus 9 plus 12. That will be 3. And these ones here will just be what? Picometers. Okay, so we have converted from the nanometers to the picometers. Okay, so the secret is just to know the value of the prefix that you have there. Okay, if you know the value of a prefix that you have there, then you are well and good to convert the units. So any questions on this explanation? Okay, so there are no questions. Let's try to do another simple example. So just so you guys can become familiar with the idea. So for example, now I have, okay, for example, now I have 7.1 times 10 to the power 3, okay, and then I say kgs, and then I want to convert these kgs, okay, to grams. Okay, so the first thing is to identify, okay, the prefixes that you've been given. So here I have the kilo. The kilo is the same as 10 to the power 3. Okay, and then here you can see that this is just grams. It doesn't have any prefix. Okay, it doesn't have any prefix. So if it doesn't have any prefix there, it's just grams. It means the value of the prefix is just 10 to the power what? 0. Okay, so this one will be 7.1 times 10 to the power 3. Okay, and then multiplied by this kilo here is replaced by 10 to the power 3 again. Okay, and then divided by the prefix that I have to the units where I'm going. So the prefix there is 10 to the power 0. And we know that 10 to the power 0 is the same as what? 1. Any number raised to power 0 is the same as 1. Of course, you are going to find out that this is not true when you start doing with calculus. Okay, but for now, we take it as 10 to the power 0 is 1. Okay, any number raised to the power 0 is 1. So this will just be equals to, this is 7.1. And then here I'm multiplying things that have the same base, right? So I just have to add their powers. So it will be multiplied by 10 to the power 3 plus 3. So that will be 6. And then 10 to the power 0 is 1. So this will just literally give me the same number. So it will be 7.1 times 10 to the power 6. And then the units now are what? Grams. Okay, so that's how we do the conversion by the metric system. Okay, so any questions there, guys? Any questions there? I have more examples that we need to do so that we just understand this. But any questions so far there? Okay, so if there are no questions, let's look at more examples now. So we're going to look at 5 examples involving length. We're going to look at 5 examples involving mass. We're also going to look at 5 examples involving volume. And then afterwards, I'll give you an assignment, which is this assignment here. And then you're supposed to solve those questions, and then you actually present your answers. I had someone.
Just a minute.
Oh, someone
Yes,
has a
yes, it's
question?
Emmanuel. Yes, my phone was jamming. This is one of the doing. So now the network wasn't good here.
Okay,
So I don't know if you can explain again on the previous example.
this one here.
Yes, sorry, this is one of doing you guys. My phone and the network here was bad, so this is when I'm able to get a clear picture.
Okay, no problem. I'll
So I
explain.
didn't, yes,
All right,
yes.
so here
So,
we were asked to convert 7.1 times 10 to the power 3 kgs. Okay, we convert it to what? To grams. So I said, since we're using conversion by the metric system, we just have to know the values of the prefixes that we have. So here the prefix was this k. Okay, so from the metric
mm,
system table that we looked at when we were doing this, we said kilo was this guy here, which has 10 to the power 3. So the k is the same as 10 to the power 3. And then when I go this side, okay, I can't see any prefix in front of these grams. So it means that the prefix value there will just be 10 to the power 0, which is the same as what? 1. Okay, so now I'll start my conversion by saying 7.1 times 10, and then I'll say times this k. Now I'm going to replace it by its value, which is what? 10 to the power 3. Okay, and then divide by
good.
the value of where I'm going there, which is 10 to the power 0, which gave me 1 there. So that's what I did. So now on top there, you can notice that I have 10 to the power 3, 10 to the power 3. So these bases are the same. Okay, so what did we learn at grade 12? We said if we are multiplying two bases that are the same, you just simply add
We
the
add the
what? Yes. So this was the 6 that we got there. And then these ones here will just be in what? In grams.
power.
Okay.
So meaning on the right side there, where is B for grams? Since
Mm-hmm.
we don't have any prefix,
Mm-hmm.
we just equate to 10 to the power 0 is 1.
Yes.
Is it a rule or
Yes, that's a rule. If you don't have any prefix, then the prefix value there will just be 10 to the power 0, which is 1. Or we can simply say it's 1.
it's 1? Then the
Yeah.
G on the page will just ignore it.
Yes. Yes, have
Okay,
you gotten that?
understood. Yes, yes.
All right. So now I was saying let's do some more examples. Okay. So we'll start with the examples on length. Then we do for mass and then we do for volume. Then I'm going to give you guys an assignment. You can solve, you can send to my inbox so that you just get to practice how to solve these simple questions. Okay, so the first one there, they're saying convert 5 kilometers to meters. Okay, so I'll write 5 kilometers to meters. So the prefix here okay, is simply 10 to the power 3 because this is the kilo. And then here, it's just meters. I can't see any prefix, so that will be 10 to the power 0. Okay, so this will be 5 multiplied by, this k is 10 to the power 3, and then meters. Oh, no, not the unit, but um, just write the 10 to the power 3 and then divided by 10 to the power 0. Okay, so if the meeting cuts, just join in using the same link because we are still solving the questions. And then here, since what I have in the denominator there is just 1, so this will just be 5, sorry, to the power multiplied by 10 to the power 3. And then now the units here, we are moving from kilometers to meters. So these will be meters like that. Okay, so we have converted the first one from kilometers to meters. Okay, what about the second one? The second one, they're saying 240 centimeters to what? To meters. So again, we just need the value of this guy here, which is the cent. Okay, so we are converting 240 centimeters, okay, to what? To meters. So what is the value of this centi here? So the value of the centi is 10 to the power minus 2. And then here, it's meters. I don't have any prefix there. So that will just be 10 to the power 0. So to convert this 240 centimeters to meters, I'm just going to say 240 multiplied by the value of the centi, which is 10 to the power minus 2, divided by 10 to the power 0. So this will just be, since this 10 to the power 0 is the same as 1, this will just be 240 multiplied by 10 to the power minus 2. Okay, someone raised their hand. You have a question, sir? I saw someone raise their hand. All right, so the meters, the units here will just be simply meters. So we have converted from the 24 centimeters that we had to the what? To the meters. Okay, so let's do part 3. So part 3, we have 0.75, okay, picometers. We're converting this to millimeters. So the first thing, identify the prefixes that you have. So the pico there, okay, the pico there is the same as 10 to the power minus 12. And then the milli, okay, is the same as 10 to the power what? Minus 3. So what we have here is 0.75 multiplied by, this is the pico. So 10 to the power minus 12, then divided by 10 to the power minus 3 of the prefix where we are going there. Okay, so this will just be the same as 0.75 multiplied by, okay, 10 to the power minus 12 divided by 10 to the power minus 3. So if I'm dividing things that have the same base, then I just subtract their powers. So this will be 0.75 times 10 to the power minus 12 minus 3, like that. So this would simply be 0.75 multiplied by 10 to the power minus 12 plus 3, so that we have 0.75 times 10 to the power minus what? 9. And this answer here will just simply be in what? Millimeters, like that. Okay, so that's how we can convert the 0.75 picometers to the what? To the millimeters. Okay, so later on we are going to learn what we call scientific notation. Okay, so usually you do not leave your answer like this. You have to leave your answer in scientific notation. Okay, so in scientific notation, we need to move this decimal place one time to the right, like that. So if you move the decimal place one time to the right, then you have to subtract a 1 from the power. So that would be 7.5 times 10. Okay, I have a minus 9. And then since I've moved one step to the right, I subtract minus 1 there. And then these are millimeters. So this will be 7.5 times 10 to the power minus 10 millimeters, like that. Okay, so that's the standard. We're supposed to always leave our answers in scientific notation. Okay, so scientific notation has one rule that you guys, I think you most of the first years they do not know it. Okay, so that one rule is that this number that you are putting here, okay, it should be greater than 1, and then it should be less than 10. That's the scientific notation. Okay, so if you wrote something like 24.5 times 10 to the power 3, This one here is not scientific notation. Okay, why? Because this number that you have there is greater than 10. Okay, so the number that should be there should always be greater than 1, okay, but less than 10. That's the number that you should put there. So simply saying, if again I had maybe 0. Okay, 0, 5, just like the way it was there, and then times 10 to the power whatever power here. This here is not scientific notation. Why? Because this number that you have there is actually less than 1. So the number that you have there being multiplied by 10 to the power something should always be greater than 1, okay, but less than 10. That's what we call scientific notation. Okay, so let's look at part 4. So guys, if you have any question, just unmute yourself and then you can ask. So part 4, we have 12,000 like this, okay? Then nanometers, we're converting this to, let's make it interesting. Here I wrote meters, but let's put centimeters there. Oh, yeah, Mr. Emmanuel, you have raised your hand. You can ask.
On the scientific notation part there,
Uh-huh.
I didn't get there.
Oh, on the scientific notation, okay, we will have a lesson where we'll learn about that. But I was just telling you guys that scientific notation, the number that you're multiplying with 10 to the power something should always be greater than 1, but less than 10. And then I gave examples. So if I write 24.5 times 10 to the power whatever here, 7, this here is not scientific notation because this number here
Mm,
is greater than 10. That's what I said. Okay. And then if you write 0.57 somewhere there, and then you say times 10 to the power maybe minus 3. This here again is not scientific notation. Why? Because this number here, okay, is less than 1.
one.
So if now I write 2.1 times 10 to the power 3, this here, yes, is scientific notation. Why? Because this number that I've written there, it's between 1 and 10. That's what I was saying.
Understand.
Okay. So on number 4, let's make it interesting. This was nanometers to meters, but let's make it maybe to gigameters. Okay, so we're changing to gigameters. So what are we going to do? Just identify the prefixes. So this is nano. Nano has the value 10 to the power minus 9. The giga, okay, has the value 10 to the power positive 9. So this one will be 12,000, okay, multiplied by the nano is 10 to the power minus 9. And then I divide this by 10 to the power 9. Okay, what would this give me? So this would be the same as 12,000 multiplied by 10 to the power minus 9 divided by 10 to the power 9. So which simply means we have 12,000. And then this one here, since the bases are the same, it will be multiplied by 10 minus 9, then minus 9, like that. So it will just be 12,000 multiplied by 10 to the power minus 18. Okay? And then we can want to express this number now in scientific notation. You see that this number here is greater than 10. So whatever I've written there is not scientific notation. So this number has the decimal point at that place. So I have to move that decimal place until the first 2 digits are greater than 1 but less than 10. So I'll move this decimal place 1, 2, 3, and then 4. So that would be 1.2, okay? And then if you want, you can add the zeros. If you want, you can't add them, okay? So multiplied by 10 to the power minus 18. And then since I moved this decimal place 1, 2, 3, 4 times to the left like this, then I have to add the 4 to the power. Okay, because I'm moving to the left. So it's like opposite. When you're moving to the left, you add. When you're moving to the right, you subtract. So what is minus 18 plus 4? Okay, so that one is just going to give me minus 14. So the final answer there in scientific notation will be 1.2 times 10 to the power minus 14. And this will be what? Gigameters, like that. Okay, so let's look at the last one on length. We move to mass. So now here we have 3.5 kilometers. We are converting it to centimeters. So it means here, this kilo here is just 10 to the power 3. This centi here, okay, it's 10 to the power minus 2. So this will be 3.5 multiplied by the kilo, which is 10 to the power 3, divided by 10 to the power minus 2. And this here is the same as 3.5 multiplied by 10 to the power 3 over 10 to the power minus 2. So the bases are the same. We do what we've been doing. So 10, 3 minus 3. Okay. So make sure you put the minus 3 as it is like that. This one is, this minus here is because we are dividing these things. So this will just be 3.5 multiplied by, we have 10 to the power 3, negative and negative, that gives you plus 2. So that would be 3.5 times 10 to the power what? 5, and this will be centimeters like that. Okay, that would be centimeters like that. All right, so we're done with the examples on length. Unless you guys have questions, I'm going to move to the examples on mass. So, but we will just be doing the same thing. So I just want us to practice a lot of questions so that these concepts actually able to enter your heads. So mass examples. Okay, so the first one, convert 4,500 grams to kilograms. So this one will be 4,500 grams. We are converting it to kilograms. Okay, so here we see that we do not have any prefix here. So that is 10 to the power 0. Then here it's 10 to the power what? 3. So this will be 4,500 times 10 to the power 0 divided by this guy here, 10 to the power what? 3. So this will just be 4,500 times, I can combine this part here. So since the bases are the same, I'm just subtracting the powers. So that is 0 minus what? 3. So that is 10 to the power minus 3. Okay, and then if you want to put it in scientific notation, in this number, it means the decimal place is there. So I'm moving 1, 2, 3 times. So that would be 4.5 times 10 to the power minus 3. And then I've moved 3 times to the left. So I'm going to add plus 3. So that will just be 4.5, okay, times 10 to the power minus 3 plus 3. That is 0. So this will just be 4.5 what? Kg. Okay, so 4,500 grams, the same as 4.5 kg. Okay, so here I can even show you the other method that you guys are used to, the one that you are using in secondary school. So we used to say at 1 kg is the same as 1,000 grams, right? So we can use it here. So we can say 4,500 grams is equals to x. And then we used to cross multiply. So 1,000 and this x, it gives me 1,000 x is equals to 1 by this, it gives me the same number. And then I divide by 1,000, divide by 1,000. Okay, x is equals to, here I cancel 0, cancel 0, cancel 0, cancel 0. And then 45 divided by 10, I get my 4.5 kilograms. Okay, so you can see that that's exactly what we are doing in secondary school. But here, we're just making it in a formal, standard way in which you can find it. Okay, and you can, okay, uh, you can actually use even this method at the university. It's up to you. But me, I'm just showing you an easier one. Okay, uh, in case uh, in case you forget the conversion factors, because these ones here, the one that I wrote here, like 1 kg is equals to 1,000 grams, that's a conversion factor. So in case you forget the conversion factor, then the metric system is going to save you. Okay, so that's what we can do there. Let's look at number 2. So number 2, they're saying 0.08 kgs. Let's convert this to picograms. Okay, so I'm just going to get this 0.08 multiplied by this, now the kg, by now we are used, is 10 to the power 3, right? Divided by this pico. Okay, pico is the same as 10 to the power minus 3. Hey, minus 12, sorry. So this will just be 0.08 multiplied by, okay, 10 to the power 3. And then this one, since it's in the denominator, it will be minus 12. So this will just be 0.08 multiplied by 10 to the power 3 plus 12, so that we have 0.08 times 10 to the power what? 3 plus 12, that would be 15. And then I can put this in scientific notation. You can see that this number is less than 1. So I have to move this decimal place, okay, such that I have a number which is greater than 1 but less than 10. So the point is there. So I'll move it to 1, 2. Okay, so that will just be 8. Okay, because the decimal point is now on the right side of the 8. And then multiplied by 10 to the power 15. Then since I've moved to the right, I have to subtract a 2 from this power since I've moved 1, 2. So that will just be 8 times 10 to the power 13. Okay. And then this will be picograms. Okay. So that will be picograms there. All right. So any questions there, guys? Okay. Let's convert another one. So the other one is this guy. So this is 265 milligrams. Then we are converting this to micrograms like this. So as usual, we just have to know the value of the prefixes there. So the prefixes there, it's milli, and then here it's micro. So this will be 265 multiplied by this milli here. When you come on the metric system, it's this guy. So that one is going to give me times 10 to the power minus 3, right? And then I divide by where I'm going there, which is, this is the micro, right? So the micro is 10 to the power minus 6. So this will be the same as 265 times it. And then here I have 10, 10. So this will just be 10, okay, to the power minus 3. And then since this one is in the denominator there, so it will be minus 6. So this will be 265, okay, multiplied by 10 to the power minus 3. And then there it is the minus multiplied by minus, right? So it will be plus 6. So this will just be 265 times 10 to the power. What is minus 3 plus 6? That is positive 3. And then we put it in scientific notation. So this 265, the decimal place is there. So I move it to 1, 2. So that will be 2.65, okay, multiplied by 10 to the power 3. And then I've moved 2 steps to the left, right? So I have to add a 2 there. So that will just be 2.65 times 10 to the power 3 plus 2. So that will be 5. And then these ones here are just simply micrograms. Okay, so any questions there? Okay, so there are no questions. Let's move to the next one. So I'm making sure we do as many questions as possible. So the first one here is, the next one is 5.2 nanograms. We are converting these to megagrams. So what are we going to do there? So the nano is 10 to the power minus 9. This mega here is 10 to the power 6. So this will be 5.2 times the nano is 10 to the power minus 9 divided by where we are going, 10 to the power 6. So here, this is the same as 5.2. Then we can combine this part, right? Okay, so that will be 10 to the power minus 9, then minus this 6 here. So 6. So that will just be 5.2 multiplied by 10 to the power, here we have minus 9 minus 6, so that is minus 15. And this one is already in scientific notation. So this will just be megawatt grams, like this. So 5.2 nanograms is the same as 5.2 times 10 to the power minus 15 megagrams. Okay, so, all right. Let's go to the other one. So the other one here, okay, I'll skip this part here. You can try this one. Okay, because I've handled the one with the kg and the milligrams before. And then maybe we can solve this one. So this is 3.6 gigagrams. Then I'm converting it to milligrams. So the giga, as usual, is just 10, okay, to the power 6. That's the giga. Divided by the milli. Okay, the milli is 10 to the power minus 3. So this will be 3.6 times 10. Then I can combine the powers. Since I'm dividing this, it will be 6 minus, and then the power in the denominator, which is minus 3. So this will be 3.6 multiplied by 10 to the power 6, okay, plus 3, because negative and negative gives me a positive. So this will be 3.6 times 10 to the power 9. Okay, so that would be milligrams now. So 3.6 gigagrams, okay, it's the same as 3.6 times 10 to the power 9. Okay. All right. So any questions there? So we've solved some examples on length. We've solved some examples on mass now. So can we move to the volume part? So any questions there before we move to the volume part? Okay, so if there are no questions, I'll move. So we now talk about volume. Okay, so what we're going to be doing is just the same thing. Okay, so as long as you know the metric system table, you know the multiples of 10, the submultiples of 10, then you're good to go. Okay, you're good to go. So let's do some, maybe 3 from here. So the rest you can actually do them. So we start with the first one. So there's 3.5 liters. I want to convert this to milliliters. So you see that here, there is no prefix. So that's just 10 to the power 0. Here there is milli. Milli is 10 to the power minus 3. So this would be 3.5 multiplied by 10 to the power 0 divided by where we are going, which is 10 to the power minus 3. So this will just be 3.5 multiplied by 10. Then I combine the powers there. So that is 0 minus this minus 3. So minus 3. So this will just be 3.5 multiplied by 10 to the power 0. And then this minus multiplied by the minus 3 is going to give me a positive 3. Okay? So this will just be milliliters like that. So we have converted from the liters to the milliliters. Okay, so let's look at the second one. So the second one is 870 milliliters. We are converting this to picoliters. So this would be 870 multiplied by the milli, it's the same as 10 to the power minus 3, divided by the pico, okay? The pico is this guy here, which is the same as 10 to the power minus what? 12. So if I combine this, it will be 870 multiplied by, this is 10 and 10. So that will be 10 to the power minus 3, and then minus, since this guy is in the denominator, right? So minus 12. So this will be 870 multiplied by 10 to the power. This will be minus 3 and then plus 12. So this will just give me 870 multiplied by 10 to the power 12 minus 3, or minus 3 plus 12. That would be 9. So this one will be picoliters. Okay. So we can actually express that in scientific notation. So I move the decimal place because the decimal point, it will be here. So I move it to 1, 2. So that will be 8.7, okay, times 10 to the power 9. And then since I've moved 2 steps to the left, I have to add a 2 there. So that will just be 8.7 multiplied by 10 to the power 11, like that. So that will be picoliters. Okay, so let's look at third one. And then the rest, I'll leave it for you guys to try them out. So you can send the answers to my inbox. Then I'm going to correct you if what you're doing is correct or it's wrong. So this one, I have 0.004 deciliters. I want to convert this to milliliters. Okay. So what am I going to do? So I'm going to get the prefix value for the DSC. Okay, so the DSC is 10 to the power minus 1. The milli is 10 to the power minus 3. So this will be 0.004 multiplied by 10 to the power minus 1 divided by 10 to the power minus 3. So that will just be 0.004 times 10. Then I combine the powers. So that is minus 1 on top minus the minus 3 down. So this will give me 0.004 multiplied by 10 to the power, this will be minus 1, and then minus and minus, they give me a positive. So that will be like minus 1 plus 3. So when I combine this, it will just be positive 2. Okay, and then I want to express this in the scientific notation. So I'll move this point here from this guy to that point. So it will be 1, 2, 3. So that will just be 4 multiplied by 10 to the power 2. And then I've moved how many times to the right? I've moved 1, 2, 3. So if I've moved to the right, then I subtract by that many times that I've moved. So that is minus 3. Then that will just be 4 multiplied by okay, so 4 multiplied by 10 to the power, this will be what now? 2 minus, how many times have I moved? 1, 2, 3. Okay, so 2 minus 3, that would be minus 1. So that would be the answer there, and that would just be milliliters like this. Okay, so any questions there, guys? Any questions that you have on whatever we've done? Because the class is done. Okay, I've taught you guys how to convert the units using the metric system. Okay, so if there are no questions, we end here for today in chemistry. This was our first class in chemistry. Okay, so meaning that in the next class that we'll have for chemistry, we are going to look at how we can convert dimensional analysis. Okay, when we have those measurements with 2 units, like maybe 5.2 grams per cubic centimeters. Okay, and then they ask you to change this to grams per, maybe they say meter cubic. How can you convert such units? So that's what we call as dimensional analysis in chemistry. But in physics, it's going to have a different meaning. In physics, it will mean you're confirming the uniformity of the units. But here, we're going to be using it to change the units. Okay, so the next class in chemistry, we're going to look at dimensional what? Analysis. Okay, so I have an assignment for you guys here. So those are the questions that you can try out together with those that have left. Someone is writing on my screen. I don't know who. Okay, so together with those that have left, like this one and this one, you can try them out together with this assignment that I've given here. So you can take a screenshot. Okay, you can take a screenshot and then you just try to solve them. Okay, so once you solve them, you can share them in the group. You discuss amongst yourselves as friends, or you can send it to my inbox. My number is written Tutor Poor Solutions. You're going to see it in the group. So you can share it with me, and then I'll see what you're doing. If it's correct, I'll commend you. If it's not, I'm going to correct you so that you know how to convert what? These units. Okay, so that is it for today. But before you go, I want to show you guys our website. Okay, so we offer lessons for NS math, biology, physics, chemistry. Okay, so we offer the 4 NS courses. So we have actually a website that has lessons on everything that you guys are going to learn under NS. Okay, so this website, the name is discretelearning.com. So those who are ambitious enough, okay, you can go there and you try to check it out. So I'm just waiting for it to load. So you can see this is the website here. Then when you go down here, you can see the 4 courses under NS. So there's math, there's chemistry, there's physics, there's biology. Okay, so when our free lessons end, okay, we are only going to be teaching those that will be registered with us. Okay, so for you to register with us, you have to register using the website, and all the recorded videos that we are going to be doing, we are going to be posting them on the website. Okay, so for example, let's check out this same chemistry that we are doing. So if I open the chemistry course, okay, you go in this course, in this folder written general chemistry. Okay, so if you go in the folder for general chemistry there, you're going to find 5 folders. So there's this folder for the lessons and tutorials, this one here. Okay, so here you're going to find lessons on every topic that you're going to cover under chemistry. Okay, here they are handwritten summarized notes. So well summarized notes, simplified, direct to the point of whatever you need to pass the exams. So you're going to find them there if you open this folder. And then here we have the tutorial sheets and the assignments. Okay, so in case you're given assignments, tutorial sheets, we're going to record videos, plus we are going to provide written solutions. We are going to upload them there. So you can find them there. And then here in this folder, you're going to find the past quiz, test, and exam papers. Okay, so you're going to be finding videos there for past quizzes, for past tests, and past exam papers so that you can be learning. So uh, we offer 2 types of learning. So there's this live one, like we are doing right now. So you're able to ask questions, and there's also uh, the recorded part where you just access the recordings that you want. So if you go maybe in the folder, maybe for exam past papers, okay, you go to the exam that they wrote last year. Okay, you're going to find the video uh, explaining whatever questions were there. So if you open these lessons and tutorials, let me just show you. You're going to find, you can see there are folders there. So there's introduction to chemistry, units and measurement. Whatever I've taught today, I've already taught it before. So you can see there are all these folders for different topics that you're going to cover. So from introduction to chemistry all the way to nuclear chemistry. But you guys don't do nuclear chemistry anyway. You end at organic chemistry. So all these topics you can see in front here, you have to know them. Yeah, so you have to know them, and we've recorded classes so you can learn at your own time. So those who are ambitious enough, you can actually check out our website. Okay, you can subscribe. You're going to find these things here. But for now, okay, from today, so this week, even next week, we're just going to be offering free lessons. So everyone can attend, everyone can learn. Okay, but after the 2 weeks, um, it's only going to be those who are subscribed. Okay, so thank you so much for attending this class. Okay, I can't wait to see you again in the next one. So at 19 hours, you're going to have a math class. So you're going to be talking about sets. That class will be with Tutor Marius. Okay, so I hope you guys enjoyed this class, and we are very happy to have you on our platform. All right, so any questions before I close the class? Okay, see you guys then. Don't forget to try out the assignments. I'll be waiting for your answers.